grounded wire, also known as a neutral, can be used to provide 120 volts power under specific conditions. Firstly, the generator must be a 3-phase 4-wire system. This implies it needs 3 ungrounded or hot conductors and 1 grounded or neutral conductor. Secondly, the motor starters intended for use must be rated for 120 volts 3-phase operation. To connect the motor starters for 120 volts, follow these steps. 1. Connect the 3 hot conductors to the 3 input terminals of the motor starter. 2. Connect the neutral conductor to the neutral terminal of the motor starter. 3. Connect the other side of the coil to the ungrounded hot conductor that is not connected to the motor starter's input terminals. This configuration creates a 120 volts, 3-phase circuit. The 3 hot conductors collectively provide the 240 volts phase-to-phase voltage. By connecting the neutral conductor to one of the hot conductors, you effectively establish a 120 volts phase-to-neutral voltage. This specific phase-to-neutral voltage is then utilized to power the motor starter's coil. It is crucial to understand the role of the grounded conductor in equipment grounding. The grounded conductor serves as a low resistance path, allowing fault currents to safely flow back to the generator. Important safety precautions to keep in mind are: do not connect the grounded conductor to the chassis or frame of either the generator or the motor starters. This is a critical safety measure. It's always necessary to adhere to proper electrical safety precautions when dealing with electrical equipment. Prior to connecting any loads, ensure that the generator is properly grounded. Use only motor starters that are specifically rated for the voltage and current requirements of the motor they are intended to control. Refer to the manufacturer's instructions for the correct installation and operational procedures for both the generator and the motor starters. These instructions provide essential guidance for safe and effective use. Electrical systems and safety protocols are paramount. Always energize equipment before working on it. Use appropriate personal protective equipment such as insulated gloves and safety glasses. Double-check all connections before energizing the system. Fault current should always have a clear, low impedance path back to the source. Never bypass safety devices. Understanding grounding is crucial in electrical systems. Grounding provides a safe path for fault currents, protecting equipment and personnel. Grounding systems should be regularly inspected and tested to ensure they are functioning properly. Ground impedance should be measured to verify its effectiveness. Grounding electrodes should be properly installed and maintained. Also, refer to the National Electrical Code, or NEC, for detailed requirements on grounding and bonding. Bonding ensures that all metallic parts are electrically connected, providing a low impedance path for fault currents. Bonding conductors should be sized according to the NEC. Bonding should be continuous and reliable. Incorrect grounding and bonding can create dangerous conditions, increasing the risk of electrical shock and fire. Before working on any electrical system, it is important to understand the specific grounding requirements. Different types of grounding systems exist, such as grounded, ungrounded, and impedance-grounded systems. Each type of system has its own advantages and disadvantages. The selection of the appropriate grounding system depends on the application and the specific requirements of the electrical system. Ground fault protection devices can help to minimize the risk of electrical shock and equipment damage. These devices detect ground faults and quickly de-energize the circuit. Ground fault circuit interrupters, or GFCIs, are commonly used in residential and commercial applications to protect people from electrical shock. Ground fault protection is especially important in wet or damp locations. Surge protection devices, or SPDs, can protect electrical equipment from voltage surges caused by lightning or other events. Surge protection devices should be installed at the service entrance and at sensitive equipment. Regular maintenance and testing of electrical systems are essential for ensuring safety and reliability. Inspection of wiring, connections, and equipment can identify potential problems before they cause a failure. Insulation resistance testing can detect deterioration of insulation, which can lead to ground faults. Thermographic imaging can identify hot spots in electrical equipment, which can indicate loose connections or overloaded circuits. Proper labeling of electrical equipment can help to prevent mistakes and ensure safe operation. Labels should clearly identify the voltage, current, and other important information. Warning labels should be used to alert people to potential hazards. Training and education are essential for electrical safety. People who work with electrical equipment should be properly trained in safe work practices. Training should cover topics such as grounding, bonding, lockout, tagout, and personal protective equipment. Continuing education is important to keep up with changes in technology and safety standards. The NEC is a comprehensive set of standards for electrical safety. It is updated every 3 years to reflect changes in technology and best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is important to consult the NEC for specific requirements related to electrical installations. Local codes and regulations may also apply. These codes may be more stringent than the NEC. It is important to check with the local authorities to determine the applicable requirement. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment should be aware of the potential hazards and take steps to prevent accidents. By following safe work practices and adhering to applicable codes and regulations, you can help to ensure a safe electrical environment. Remember to consult with a qualified electrician for any electrical work that you're not comfortable performing yourself. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to do the job safely. A qualified electrician can ensure that the work is done correctly and that the electrical system is safe and reliable. Before undertaking any electrical project, it is important to plan carefully and to obtain all necessary permits and approvals. Planning should include a detailed assessment of the electrical load, the wiring requirements, and the safety considerations. Permits may be required for certain types of electrical work. It is important to check with the local authorities to determine the permit requirements. In addition to the NEC and local codes, there are other standards and guidelines that may be relevant to electrical safety. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEEE, and the National Fire Protection Association, or NFPA. These standards provide detailed information on specific aspects of electrical safety, such as grounding, surge protection, and arc flash protection. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in electrical equipment. Arc flash can produce extremely high temperatures and can cause serious burns and other injuries. Arc flash protection requires specialized equipment and training. An arc flash hazard analysis should be performed to determine the level of protection required. The analysis should consider factors such as the voltage, current, and clearing time of the electrical equipment. Personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields, can protect workers from arc flash hazards. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance and repair. These procedures require that the equipment be de-energized and that a lock and tag be attached to the disconnect switch. The lock and tag prevent the equipment from being energized until the work is completed. Training in lockout-tagout procedures is essential for workers who perform maintenance and repair on electrical equipment. Power quality is an important consideration for electrical systems. Poor power quality can cause equipment malfunction, premature failure, and increased energy consumption. Power quality problems can include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Power factor correction can improve the efficiency of electrical systems. Power factor is a measure of how effectively electrical power is being used. A low power factor can increase energy consumption and can overload electrical equipment. Power factor correction capacitors can be used to improve the power factor. Harmonics are distortions of the voltage and current waveforms. Harmonics can be caused by nonlinear loads, such as electronic equipment and adjustable speed drives. Harmonics can cause overheating of electrical equipment, increased energy consumption, and interference with communication systems. Harmonic filters can be used to reduce harmonics. Electrical systems should be designed and installed to minimize the risk of electromagnetic interference, or EMI. EMI can interfere with the operation of sensitive electronic equipment. Shielding, grounding, and filtering can be used to reduce EMI. Energy efficiency is an important consideration for electrical systems. Energy-efficient equipment and practices can reduce energy consumption and save money. Energy-efficient lighting, motors, and transformers can significantly reduce energy consumption. Regular maintenance and testing can ensure that electrical equipment is operating efficiently. Renewable energy sources, such as solar and wind, can be used to generate electricity. Renewable energy sources can reduce reliance on fossil fuels and can reduce greenhouse gas emissions. Solar panels convert sunlight into electricity. Wind turbines convert wind energy into electricity. Energy storage systems, such as batteries, can store energy generated from renewable sources. Smart grids are electrical grids that use advanced technology to improve efficiency, reliability, and security. Smart grids can monitor and control the flow of electricity, optimize energy consumption, and integrate renewable energy sources. The NEC provides requirements for the installation of renewable energy systems and smart grid technologies. High-voltage electrical systems require specialized equipment and procedures. High-voltage systems are used to transmit electricity over long distances. High-voltage equipment includes transformers, circuit breakers, switches, and insulators. High-voltage work requires specialized training and equipment. Safety precautions are essential when working with high-voltage systems. Substations are facilities that are used to transform voltage levels and to switch electricity between different circuits. Substations contain high-voltage equipment and require specialized security measures. Regular maintenance and inspection of substations are essential for ensuring reliability and safety. Electrical safety audits can be used to identify potential hazards and to ensure compliance with safety standards. Audits should be conducted by qualified professionals. The audit should cover all aspects of the electrical system, including grounding, bonding, overcurrent protection, and arc flash protection. A written report should be prepared that summarizes the findings of the audit and recommends corrective actions. It's crucial to understand that if a generator is designed to output 240 volts three-phase and you are intending to derive 120 volts from it, you're essentially creating a single-phase load on a three-phase system. It's important to ensure that the load is balanced across all three phases as much as possible to prevent voltage imbalances and overheating of the generator. Also, be aware of the generator's capacity. Exceeding the generator's rated output can damage it and lead to power failures. The grounded conductor, or neutral, should be properly sized according to the NEC to handle the anticipated current. This is crucial for safety and proper operation of the system. Before making any connections, double-check the wiring diagram for both the generator and the motor starters to ensure compatibility and proper configuration. If there are any doubts or uncertainties, consult with a qualified electrician to avoid potential hazards and ensure compliance with electrical codes. Consider that some generators might have specific requirements for neutral grounding. Some generators might require a solid neutral ground, while others might use a high resistance ground or a floating neutral. The type of grounding system can affect the performance and safety of the system. Always refer to the manufacturer's specifications for the generator to determine the appropriate grounding method. When connecting the 120 volt circuit, be aware of the current carrying capacity of the wires. Use appropriately sized wires to handle the expected load. Undersized wires can overheat and cause a fire hazard. Consider using a separate overcurrent protection device such as a circuit breaker or fuse for the 120 volt circuit. This will help to protect the circuit from overloads and short circuits. The overcurrent protection device should be sized according to the wire size and the expected load. In addition to grounding, bonding is also important for electrical safety. Bonding is the practice of connecting all metallic parts of the electrical system together to create a low impedance path for fault currents. Bonding helps to prevent voltage differences between metallic parts, which can reduce the risk of electrical shock. Be sure to bond the generator frame, the motor starter enclosures, and any other metallic parts of the system together. The bonding conductors should be sized according to the NEC. Remember that working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. To energize the circuit before working on it, use insulated tools. And never work alone. If you are not comfortable working with electricity, hire a qualified electrician.